Hello grade 12s, it's wonderful to be with you again. Are you making good progress with your practical assessment task? I hope so. It's actually quite logical, as long as you plan everything step by step. In our previous lessons, we looked at phase 1 and many parts of phase 2. For example, we learned about program specifications, algorithms, IPO tables and classes, objects and data flow. In our last lesson, we started learning about how to store data in databases. And you can see here that we'll continue with databases in today's lesson. Good morning, Thabo. Oh, you're looking at your IPO tables again.
Hello. Yes, I tried out some of the things we learned last time. I found that looking at my IPO tables, class diagrams, and data flow diagrams really helps me to identify the data that needs to be stored permanently.
That sounds good. I can see that you know what data has to be stored. Have you worked out where and how to store it?
I'm checking that. There is some to store in a database and some to store in a text file.
Great, Thabo. In the last lesson, we looked at all the factors to consider when data is stored in databases and in text files. Today, we're going to continue with databases to learn about sorting data items, primary keys, and lookup tables and queries. This should be really helpful. By the end of this lesson, you should be able to sort data items according to the entity of each item, determine natural fields and add suitable primary keys, add foreign fields where relationships between tables must be created, determine appropriate data types for fields, and prepare a list of queries, reports, and table manipulation. Okay, let's get back to the database. Thabo, you made a document in which you recorded some of the tables and fields you need.
It had a learner's table for the first name, surname, username, and password. A terms table with the term field and 2 new fields, times asked and times wrong, and a definitions table. So that's it. We have a database.
Not quite. There is still some work to do. There are a few golden rules to remember when it comes to storing data in a database. Remember, don't store any fact you are not going to use. Don't store any fact that can be obtained from other stored facts. Don't store any fact in 2 different places. And break down a complex fact into a few simple, useful facts. By the way, when we say fact, we are referring to the fields. Once you have all the facts, you must first design the separate tables. Sort data items according to the entities they belong to. In other words, put the fields into the correct tables. Then determine all the essential natural fields. This is about adding fields you may have forgotten and removing fields you don't need. Then you add a suitable primary key to each table. To summarize, sort data items according to its entity. Determine all the essential natural fields. Then add a suitable primary key to each table. Once you have all the tables, you need to show the relationships between the tables. Entity Relationship Modeling, or ERM, is one of the tools we use to design database tables. Before we look at an ERM diagram, let's make sure you understand the terms. What is an entity, Thabo?
If I remember correctly, it's anything that exists. It can be a person, an object, an event, or an idea.
That's right. It can be distinguished clearly from another entity. Each entity has certain attributes which are the properties belonging to the entity. and can have a relationship with another entity. I always think of entities and their attributes as nouns and relationships as verbs. For example, you, Thabo. You are a learner. That's a person entity. You have your own name. That's an attribute. Also, you take part in various things. That's a relationship. Like a test, which is an event entity, the relationship between you and the test is that you do the test. You get a mark. That's an attribute of the test, and the test uses things.
That's a relationship.
Things like questions and answers?
Idea entities. So there is a relationship between the test and the terms because the test uses the terms.
Correct. The relationship between the entities works both ways. A test is taken by you, the learner, and you, the learner, take a test. So we know about entities, attributes, and relationships. What about that data you have to put in your database? When you identify the facts to store in a database, you are collecting attributes of different entities. These will be fields in your tables. The categories into which you place the facts are the entity sets, the tables. If you find an attribute, a fact you need to store, that seems to belong to two entities, you must decide which entity really owns that attribute. Never store data in two places. For example, let's say you have a learner table and a game event table. If a certain learner plays a certain game, the score seems to belong to the learner and to the game. But which entity does the score actually belong to?
The learner entity?
Are you sure about that? If the score belongs to the learner, it must be a natural or normal property of a learner, like the learner's name, for instance.
Oh, so the score can belong to the learner entity. It would be his one and only score. If he played another game, I'd have to change it. But once the game is played, it's over and finished, and the score belongs to that game. The learner can play another game and get a different score.
Correct. So the score actually belongs to the game. If you wanted to store a total of all scores, that would belong to the learner. There is one attribute that is not a natural attribute of an entity, but an attribute that we must deliberately give to each entity. Humans can easily distinguish between entities. All we do is consider their natural attributes. For example, if two of your friends are both called Sam, and you get a letter from Sam, how would you know which one it's from?
You'd look at the handwriting, or perhaps the surname, or where the letter came from.
That's right. But for a computer to distinguish between different entities of the same kind, for example, different learners, each entity must have one unique attribute, not necessarily a natural one. Take cell phone numbers and identity document numbers. They are unique and meaningful to humans, but don't mean anything to a computer. The best way to help the computer tell entities apart is to add an attribute that uses simple sequential numbers like 1, 2, 3. This attribute is known as primary attribute or primary key of the entity. To draw up an ERM diagram, you need to look at the notes you made. Choose table names to suit your application. For example, in a game type program, use player instead of learner. You may need more tables than you listed in your notes. Check that the fields will be placed in the table they belong to, the natural fields of the table. Then check each field and ask yourself a few questions. Let's check again. Here the fields haven't been checked at all and may be in the wrong table. Ask yourself how you will use each field and whether you need to split it into two fields. Which field would you split, Thabo?
I'd split the learner's name into the first name and surname.
Why?
Then I could sort records according to surnames and use only the first name in messages to the user.
Then you can check each field to see whether it appears to belong in another table. Decide which entity owns the field. If a field does not seem to belong in any of the tables and it must be stored, it shows that you need another table. Look at the example again. Grade 10, or the level at which a game is played, is not a natural attribute of player, terms, or game event. Also, it shows that we have 3 different places to store the same kind of data. Another table is needed, which we can call level. A table can contain only one field if the application requires it. We must remove the grade and level fields from the other 3 tables. Note that this is one field, not one record. There would be no point in having a table which is a collection of records with only one record. There will be 3 records, grade 10, grade 11, and grade 12. Note the 2 fields where we split the name field in the players table. There are only natural fields in each table, except in terms and game event. The correct answer belongs in the answers table, and the player's name belongs to the player. It will be the player's username. We must not store data in 2 places, so we remove those fields.
But there is a relationship between the game event and the player, and between the term and the answer. Are we deleting those?
We're not deleting them or the relationships between the levels table and the other tables. You'll see later how we show relationships. Next, you check that you have not left out a field you will need. For example, you may want a different mark for each question or term asked. That mark would be a natural attribute of the term, so you would add a field named mark. Then we need to catch a primary key to each table and draw up a list to use in our ERM diagram. Make sure your table and field names are descriptive. The list will look something like this. The entities are players, terms, answers, games played, and levels. The attributes for players are player number, primary key, first name, surname, username, and password. For terms, it's term number, primary key, and term description. For answers, answer number is the primary key, answer or definition. Games played, game number, PK, date played, score, and game type, for example, multiple choice or match the columns. And for levels, the level number, PK, and name of level, meaning the grade. Do not be tempted to fill up the tables with more but unnecessary fields. You don't need addresses and cell phone numbers for game players in this scenario. Now you're ready to draw up an ERM diagram to show the database structure.
Can we use any diagram we want?
You could create the tables in MS Access and print out the relationship view. Just remember that this is the design document. Don't put too much effort into the database until the teacher has assessed it in phase 2. I will show you another table diagram. For an ERM diagram, there are a few basic guidelines to follow. Entity sets are drawn as rectangles. Relationships as diamonds. If an entity set participates in a relationship, they are connected with a line. Attributes are drawn as ovals. An attribute is connected to only one entity or relationship set, also with a line. Here is a simplified diagram showing 2 entities and a relationship. Each entity set, these rectangles, is a separate table. The natural attributes in ovals of an entity set are the fields in the table. The unique attributes is the primary key field for the table and is underlined. A foreign attribute or foreign key must be placed in an entity set or table that has a relationship with another table. Copy the name of the primary key. Here the learner ID must be added as a foreign field in the game event table. This is used to link each record in the table that holds the foreign key with the primary key field of one of the records in the other table. The foreign key field for each record in a table can only reference one primary key in the other table. But the primary key field can be referenced by the foreign fields of many of the records in the other table. This shows that one learner can play many games. For example, a learner can play many games, but each game was played by one learner. So a foreign field would be placed in the events table on the many side of the relationship and would store a learner ID from the table on the one side of the relationship.
What about a game where each question has one answer and each answer applies to one question only?
If a one-to-one relationship exists, meaning each question has one correct answer, we don't need a foreign field. All you do is link the PKs of the two tables. But in terms of good database structure, it would be better to store the terms and definitions as two fields in one table. Alright, back to your ERM diagram. To create ERM diagrams, do several rough drafts using either diagrams or lists using just pen and paper. Then use MS Word, AutoShapes or other tools for the final draft. And you can use other diagram structures, for instance, this table diagram. Table diagrams are used to show all fields. Include the new foreign fields. Also show the primary key foreign key links. Here we can see that the foreign key player will be used to look up a record in the players table, and the foreign field level will look up a record in the levels table. The grade field in the learners table will also look up a level. Now you are ready to determine appropriate data types for the fields. You should also indicate where and how field properties should be set or changed. For example, to validate input or restrict the field size, and where lookup tables will assist in maintaining consistent data input. Your best option is to supply the information in another table. Create one table for each database table, or draw up ERM diagrams. You will add notes to indicate field name, the data type of the field, the field size or format, any validation rules to be set, any input mask you might need, and whether data must be looked up from one of the other tables or from a list you will type in. Let's look at a database table for players. The primary key is always the type auto number because the database tools will allocate and control the use of the numbers. The field sizes of any text should be restricted. Here, the name fields must be checked to ensure they are not left blank. Note that in this case, the username and password will be validated by the program, not by the database tools. The password will have an input mask, so it is not visible in the database table. If only the administrator will see the data in the table, a mask will not be needed. In the lookup column, we show what is being looked up. The foreign key will look up a record in the levels table. I have added the field house as an example. The stars indicate it does not belong in this table. It shows how you could look up which house a player is in from a list you will type in. This helps to avoid inconsistent data and spelling mistakes. Remember to use the same format as in the example for each of your database design tables. Here's your task for today. Draw up a table of information for the games played table. In your table, indicate field name, data type of the field, field size or format, validation rules to be set, input mask you might need, and whether data must be looked up from one of the other tables or from a list you will type in. And notice that there is an extra field, game type, for recording, whether the game played was a multiple choice or a match the columns game. That brings us to the end of the lesson. Until next time, work hard at your pet.